Hello, everybody. Welcome to another episode of Visual Studio Toolbox Live. I am your host, Leslie Richardson, and today I'm really excited as a debugging gal. We are going to be talking about debugging, and to help me out with that today, I am joined by Senior Program Manager Mark Downie on the Visual Studio debugging team. Welcome, Mark.
Hi there. Thanks for having me.
Yeah, thanks for being here. So, debugging's already tough enough, but today in particular, we're going to be talking about dump debugging and how that can improve your life a lot more, right?
Yeah. So as you mentioned, debugging in your kind of like what we refer to as the inner loop already comes with a certain set of skills that you need to kind of develop over time. But then imagine now you kind of have to think about what's going on in your production environments, and you kind of want to find out at the most opportune time, you want to find out what's going on with your process. And can use as a kind of mechanism of almost last resort. You can kind of do that by capturing memory dumps and kind of opening them up in Visual Studio. It gives you the opportunity to kind of use those same debugging skills you've kind of developed over years and kind of think about how you might want to solve a certain set of problems if you can capture the dump at the right time.
Cool. Yeah, so that's really exciting. I feel like dump debugging is kind of a niche part of debugging in some extent. I personally didn't know what dump debugging was until I got into debugging more on the Visual Studio team. So, and can you talk a little bit more about why people should definitely use dumps and debug them?
Right. So in your environment in production, the likelihood of you being able to actually stop a process at any given moment while it's actually serving your customers is not very high. You probably don't want to set a breakpoint, connect your debugger to your production machine, and stop the process while serving, potentially thousands of customers simultaneously. What a memory dump allows you to do is to relatively quickly at least, take a snapshot of a particular moment in time. So you may say to yourself, when a particular exception occurs, I want to capture a snapshot of what's going on. And what that snapshot does, if you can imagine if you were in Visual Studio doing normal debugging, a snapshot would be equivalent to setting a breakpoint at a particular line of code. So if I were at that breakpoint, I could use all my fancy debugging skills to kind of inspect variables and find out what data was kind of in memory at the time. I can look at maybe the parallel stacks window and start to see what the threads were doing or what tasks were doing. I can switch and look at the call stacks of various threads while debugging. And so what a memory dump allows me to do, capturing a memory dump allows me to do, is to set the breakpoint in production, as it were. It will, as quickly as possible, it stream all that data to a file. And from that file, I can move that dump file to a machine that I have Visual Studio installed and start looking at what the potential problems may be. And so one of the things I guess we kind of encourage is to kind of get used to the tools that help you capture the memory dump at the right time. And then that allows you to kind of start the process of analysis in your Visual Studio session.
That's great. So it sounds like you get a sense of the issues that you're having at the production level, because what happens at the production level can be completely different from if you were just running it on your own machine before you scaled up, right?
Exactly. So there may be issues that only occur at scale, right? And in fact, a couple of the examples I've got today are literally issues that generally only occur when you've got thousands of concurrent requests, which is not likely to happen as you kind of debugging step by step through your application, through your source. So this is an opportunity to kind of get a sense of what's going on. You can decide I'm going to take a memory dump while my customers are, at the time, maybe Christmas shopping time, because you didn't understand why everybody all of a sudden starts to getting to their checkout time takes a lot longer during the Christmas time. You may say to yourself, I need my developers to understand what's going on at this particular moment. And a memory dump is the highest fidelity artifact we can collect that gives you the most information you can get about what's going on away from your machine.
Good to know. So just getting a piece of that moment in time while in production seems really helpful. So how do we even get started with analyzing a dump or a memory?
Right. So I think Yeah, so I think the first thing is to get used to the tools out there. A couple of the tools you might consider, for example, one of the ones I like is ProcDump from sysinternals. In fact, that might be my favorite. That's a tool we provide. ProcDump is a command line tool, and you have all kinds of settings for ProcDump. You can say, capture a memory dump when my CPU goes above a certain value. CPU goes a certain value. Capture a memory dump when my memory dump gets to a certain value, or capture a memory dump as soon as the process crashes. All these kind of scenarios are taken care of with ProcDump. So you can literally, with a few switches, you can kind of dive into collecting a snapshot when a Stack Overflow exception occurs. All these kind of scenarios you may be thinking of. In fact, it also has some really interesting options around CLR counters. So for example, if something like a thread pool thread count is too high, I can decide to take a memory dump. All these are scenarios I probably wouldn't think of or have a problem with while I'm kind of doing local debugging. So ProcDump's one tool I like. There's also CreateDump, which is a company. Visual Studio, actually, you can actually take memory dumps in Visual Studio as well. So for example, if I'm debugging an issue and it really is occurring on my machine, I can take a memory dump in Visual Studio and share that memory dump with another developer, and he can open it up and see exactly what I was experiencing at that particular moment. There's also tools like WinDBG. Those are slightly more complex tools because they don't necessarily think about managed scenarios as much. They think about, they really are kind of native first experiences for production debugging. WinDBG is a fantastic tool for capturing and analyzing dumps. In fact, WinDBG is probably a really first-class tool for looking at all the possible scenarios you possibly can. However, as a developer, you may be more comfortable starting debugging with Visual Studio because you kind of got used to a bunch of the tools inside there. And I think finally, the other one I would suggest would be Debug Diag. That's another great tool for capturing dumps and for analyzing them as well.
That's great. So there's a lot of options. It
yes,
sounds like.
Definitely.
Yeah, to the point where we even have people in the chat giving Rex, Purview, somebody acknowledged as from Linux containers especially. We also got rsharp.memory as a possible one as well.
Yep. Lots of good options out there.
Sweet. Do you have a particular favorite on your end, Mark?
Mine is ProcDump. I've kind of cut my teeth with ProcDump, capturing things for customers in the past. Again, the scenarios for my situations were mostly around why is my CPU above 80% so much of the time? So then, because essentially, if you don't capture the dump at the right time, you end up trying to build a hypothesis based on data that's completely incorrect, right? So making sure that you have those switches, correct switches that'll tell you, yes, this was captured when CPU was at 85%. Yes, this dump was captured during a second chance exception. Those are all really helpful tools to make sure you capture one. So if I had to choose, it would be definitely ProcDump. And also more recently, they've released a Linux version of ProcDump. So now you can actually run it cross-platform.
Oh, awesome. Everyone loves Crossplat.
Mm-hmm.
Right. So can you show us a little bit about how that works once you've gotten your memory dump file? Like, now what?
Sure. So you've captured your memory dump. I'd also actually kind of jump as well to say there's actually different types of memory dumps. So today we're going to look at GC dumps, which is a particular kind of memory dump. We're going to look at Linux core dumps as well, managed Linux core dumps.
Great.
And we're also going to finally then start looking at Windows dumps, which is what we're probably all most familiar with. So
GC,
to start with,
I was just going to say GC dumps. Those are garbage collecting dumps, right?
Those are dumps, basically. Yeah, those are dumps all related to the heap, basically. And just so it doesn't contain any thread information, doesn't contain any variable information. It's a particular kind of dump that I would use if I wanted to look at a memory issue, for example. So let me actually drag and drop one over here and share one on my machine.
All right.
So I'm about to drag and drop a GC dump right into here. And that should start loading here in a moment. And what a GC dump is, it basically is looking at the object graph. So there's connections and relations between anything that's on the heap. the GC dump will show it. Again, this is the kind of dump I'll take if I've just got purely a memory or a leak issue I want to look into. I want to see what's on the heap, what objects are sitting there, what did I create. And in this example, I've created this GC dump, and I'm trying to figure out why I've rapidly lost memory. This is actually the second memory dump that I've taken, and I'm going to compare it to a dump that I took previous to this, another GC dump I took previous to this, so that we can have a look at what growth there is. Because obviously I'm looking at this and this seems pretty clear to me what is taking up the most space. But in order to understand growth, I need to have a starting point. So for memory analysis, I need two dumps, one at the start of the time I'm measuring and one at the end. Yep. And then this does a fantastic diff for me, right? So now I'm able to see clearly what values increased in count and in byte size, right? So I got about an 8 meg increase. And I noticed this particular trend over only a 10-minute time span. So I know now the thing that I need to focus on. And in fact, if I go to reference types, because this is showing me the kind of connection. So I've got a some kind of static, and again, that's making my spider senses go, because I'm thinking to myself that a static object doesn't actually go away. It kind of sticks around for the entire length of the process. So if I've got a list object that's static, that's a potential opportunity for me to keep adding to a list and potentially it never getting cleaned up. So if I look here, in fact, in this reference type, when I look at the reference type, I'm getting to see now the lion's share, but indicated by this flame, it's showing me exactly where most of my memory is situated. So I can use GC dumps to quickly analyze the memory and the difference between two snapshots I've taken in production. So if your growth is taking 2 days, you may say, I'm going to take a snapshot now and 2 days from now, and I can compare them to each other. Wonderful thing about GC dumps is that they are relatively, there's not a lot of overhead with taking them, and they're relatively small. So this GC dump, for example, is about 2K or so, compared to a dump which can be multiple gigs sometimes.
Sure.
GC dumps are relatively small. Yep.
Good stuff. I really like, it's kind of the similar language that I see in the profiling tools in Visual Studio. There's a lot of similarities, like the hot icon, or whatever you call it, the kind of hot to tell you which is taking up the most space. In fact, we actually borrowed that as good prior art from our profiling team. So yes, I think that was a great improvement to this we did last year. Awesome.
Okay, I got more.
Yeah, shoot, what else you got? So yeah, that's really cool. And I do like that you can compare multiple dumps. Is it only 2 dumps at a time that you can compare, or can you do more than that?
Yeah, you can only compare 2 at the moment. If there's folks who need to do more, that would love to kind of talk to them and kind of find out how they're kind of using it. But for us, 2 seems to cover most use cases. A couple other things you can do, like if I wanted to search for a particular a data record, I can kind of literally do a search. If I don't know where my object is, for example, in this one, I kind of know what I'm searching for here. There's more data in here about the inclusive size, and that is the size not just of your object, but of all the objects it references as well. So yeah, those are the kind of important bits here. You can actually dig down. If I was just looking at one, I can dig down into the details of a record. So I can double click. I think because I'm looking at 2, let me just select one here. And so if I want to, I can analyze the data of actually I'm jumping ahead of myself. That's the Linux side. So yeah, that's basically it for our demo for GC dumps.
Good stuff. So I mean, it seems pretty simple. You can open up your GC and just
drag and drop.
Mm-hmm. And you don't really have to do any narrowing down. It seems like Visual Studio is analyzing for you. Here are the hotspots that you should check out first that could be potential issues. So
exactly, yeah.
Yeah, especially, I'm sure with the larger dumps, that wouldn't be fun trying to do that manually, right?
Yeah, it can be difficult. And this is where I think Visual Studio has some advantages over WinDBG. WinDBG, in order to interpret a dump and just looking at a dump as well, WinDBG does a fantastic job of interpreting dumps. But when it comes to managed code, that is WinDBG doesn't naturally look at managed code. You need extensions for it to do that. Visual Studio is looking at your managed parts and exactly trying to make sure it's presenting them in the way that you would normally assume to present them in your watch window or in any of the other tools that we have available.
Cool. So yeah, I mean, on the topic of other kinds of memory dumps, I think you also mentioned like managed Linux dumps.
Yes, perfect. So the wonderful thing our .NET team did over the last few months was start to cross-compile the DAC, which allows us to look at dumps no matter where you actually created them. So up until recently, we didn't have the ability to analyze Linux core dumps, a dump from a managed process running on your Linux container in Visual Studio. And so recently they've made some great changes. If you look carefully, the name of this particular memory dump here doesn't have an extension, and that's quite normal in Linux to not have an extension and not have a name, but I just simply dragged and dropped this Visual Studio. I can also do a file open and open file, and then I can go ahead and find open with, and then I could also open the dumps using, in fact, I think, yeah, I could also open my core dump using that option also. And just to kind of prove this isn't smoke and mirrors. This is a memory dump. So if we can think about what I just did previously, I took a dump at the start as a baseline. I took a dump at the end, and then we saw an increase in that particular object type. I then, at the end of that session, took a Linux core dump in addition to my 2 GC dumps. And now if I do .so, and for those folks who are more Linux oriented, you'll recognize that there's a bunch of shared objects here, which is really talking about Linux, right? In fact, you can start to see the module path in here. So this is a list of all the modules in memory when this memory dump was taken. And now I'm starting to really realize that this is genuinely not Mark tricking us. This is actually a Linux managed core dump taken from that same process. So now I can actually, with a full dump, start to do a whole nother set of investigations. I can continue, and just real briefly, I'll show you the managed memory. This is the equivalent of looking at just the heap. I'm going to cancel looking at if I can quickly capture it. And what we'll get a chance to look at is the memory, analyze the heap and look at the memory. And it should look very similar to the thing we were just looking at, because it's, again, this is a Linux core dump. GC dumps have always been kind of cross-platform format, but this is the first time we've been able to take GC dumps across Linux. And so in addition to just looking at the memory, I'm going to debug with managed only, which is the same essentially as I want to see what was happening as if I set a random breakpoint in that moment in time, and I've just taken the snapshot. So debug with managed only is my next action. I'm going to hit that. And as you can see, because the dump was just taken at some inopportune time, you can actually see here all of the ways in which I do normal debugging start to come to play, right? This just happened to be the place where this was captured. This is as if I was at a breakpoint. So now all my other windows are live, like things like this. I can look at my locals window and see what things I can see here. I can look at the call stack and see again where I was, what was being executed at this time. I can switch threads. I can actually see which thread was active at this particular moment. I can switch between threads if I want to. I can go to my parallel stacks window, one that I know that you know and love.
Yep, newly updated in recent months. Definitely check it out if you haven't seen it in a while.
So now I get a sense that this particular issue was actually a high CPU issue. And almost immediately, I can see that I've got a bunch of regexes, suggesting that there's 7 threads running similar code. And I can dive down into this and start to look at, I can look at the probable causes of my high CPU issue. Again, this is a snapshot of what was happening in production at that particular moment in time. I've pulled it into Visual Studio and I'm on my local machine. And now I can start to, in my own time, look at this, and I'm not continuously halting my customers.
Right. So your customers probably don't even realize that this is happening to an extent.
Exactly.
Right? Yeah.
Exactly. Obviously taking any artifact isn't 0 resources. So while you're actually taking the artifact, if there's, depending on the size of your process, it's not a 0 amount of resources required to take a dump. But after you've taken it, those folks are on their way and continuing their normal interactions with your service.
Sweet. So on the subject of procuring that dump real quick, we got a question from chat from Jorge. How can we set up ProcDump to collect dumps when an exception is thrown?
Cool. Good question. There is a command line. I believe it is -E. I think the best way probably is to kind of jump over to the sysinternal site, because I don't remember all of these. I don't remember all of the switches for it. But ProcDump is on the docs site. And let me see if I can grab it really quickly, if we can do this, because I'd love to answer this question.
Sweet.
So in fact, we can do this here. Let me pull this over here. So this is ProcDump on our docs, Microsoft Docs site, sysinternals. So here you've got, what I love about this particular doc is that it has all these examples of ways in which you can capture dumps. And then at the very end, it has a ton of examples. So for example, if I want to take a snapshot or a memory dump of Notepad, this is the command I would use. Or if I wanted to reference a particular PID, like by process ID in Task Manager, I could do that there as well. Let's look at a couple of other examples. I think specifically he was asking about exception, right? Was it a crash or? Okay. Just a regular.
When an exception gets thrown.
Okay, so if this is the example I think you'd want right here. So here it's saying, I want to capture an exception, first chance exception, when a exception with the name of not found occurs. So in this case, you could do it for any exception type you want. In this instance, he's looking for something called not found exception, but you could do it for whatever exception you want in this instance. And that's against the W3WP exe. There's lots of good examples here. I advise you to kind of run over there and kind of check them out.
Yeah, this is great. I love docs like this that just give all the different use cases versus you're on your own, figure it out. Stack Overflow it is,
Yeah, right. Right.
Great. And we also have one more question from chat right now. Madhusudan, forgive me if I got your name wrong, asks how can you debug dumps without PDBs?
That's a very good question. And thankfully, what we've recently released in the last few months for Visual Studio, the latest version of Visual Studio, is an option to decompile. Now, to be clear, I think PDBs would be the best option for you. They give you the best fidelity with your code. But if you wanted to kind of have a fallback option and you have the appropriate permission, then I think using our decompilation option is a really good option. In fact, that kind of leads us perfectly into our next example. How about we do our next example and I kind of lean into this topic? Is that okay, Leslie?
Yeah, let's do it.
All right, let me stop debugging here.
I love natural transitions.
Yeah, cool. All right, let me drag and drop. So the name of this next dump is going to kind of give away what the problem is here, but we'll naturally flow into some of the concerns that Madhusudan mentioned there. So I've got this dump, and what I've realized with this particular scenario is that customers are noticing that things are working slowly, things are working intermittently, it's slowing down a lot, and the CPU is low, The memory is perfectly reasonable. So it's not that kind of traditional problem. So what we've kind of been working on is a diagnostics analysis tool where we say, let's help you with some of the things that we know occur to a lot of our customers. So a lot of our customers come to Microsoft and say, hey, this is an issue. Surely it's not my code. And then we kind of turn around and say, actually, you might want to look at this, and this, because it actually
it is your code.
It actually is your code. So wouldn't it be nice if some of those tips we could just kind of give you right inside Visual Studio? So in this time, instead of running debug with managed only, which is kind of me saying I'm going to look for myself, I'm going to run the diagnostics analysis tool this time. And I'm still getting to Madhusudhan's question, so about PDBs, but just give us a moment. And so with this diagnostics analysis window, what it does is it gives you a couple of options to analyze your memory dump. You can do a memory analysis on the finalizer queue. You can do a process responsiveness, so your app is not responding in a way you'd assume. It's probably not CPU bound. So it's not kind of spiking CPU where you can't get things done, but there's some other thing going on that is stopping your process from responding to your customers. So I'm going to go ahead and hit analyze for everything, just in case, right? So I'm just going to assume it could be any of these things. And this has come back now and said to me two things. It said you've got thread pool is out of threads. And also we've got thread pool is out of threads due to blocked async methods. It's found two issues for us immediately that were frankly not obvious to me. If I were to look at the parallel stacks window, it wouldn't be obvious to me what the problem was. If I was to look at even at my code, it would be non-trivial trying to figure out what the issue is.
That's the hard part with async and threads in general, right? I mean,
a
lot of it is so obscured sometimes. Trying to figure out what exactly is the problem can be difficult.
Absolutely, absolutely. So I'm going to go ahead and select the first one and kind of walk through what that might mean. So the first one is thread pool is out of threads. And it's essentially, the summary is you're experiencing starvation. So the way I think about thread pool threads, it's like back in the old days, back when I was a young developer, we used to have to take care of our creation of threads ourselves. We would be stuck with managing the lifetime of threads ourselves. It was a pain, and it was repetitive, and it was difficult to do correctly. Mm-hmm. These days, we think about, we've kind of offloaded that work to the CLR and said, you take care of the threads for us, right? So it's almost like I turn up to a new city and I got some work to do, and they said, instead of buying a car, I just rent one, right? So the thread pool threads kind of lease you or rent you a car, rent you ability to do work. And then when you're done, you're supposed to give it back, right? Well, somebody's not giving back their threads. That's what's going on here. Somebody's just not living up to the expectations, or somebody's taking more threads than they should. They're being greedy here.
Can't all be altruistic.
That's a warning. Right, exactly. Not generous. Your code is not being very generous here at all. So what's wonderful about this analyzer is that it actually then goes about trying to help you figure out why you've got into this situation, right? Cool. And in this particular instance, it's suggesting that you have a sync over async issue. Now, sync over async issue, I think did you write about this once?
I think I did, yeah, at one point. Yeah. There's several blog posts on sync versus async and why you should care.
Yeah, exactly. So this is basically where you're doing some asynchronous work, but you've actually ended up somehow calling a synchronous function, which means you've wasted a thread pool thread doing work that you could have done synchronously in the first place, right? Yeah. So now you're kind of using two thread pool threads instead of one to do a work that you could do synchronously anyway, right? And so what happens in that situation is that you exhaust your thread pool threads twice as fast as usual. And so when you've exhausted all your threads, it's just like you showing up at the airport and there's no car for you available. Right?
So 11 o'clock at night.
Exactly. You've done it too.
Yep. Sure have.
What's great about what I like about what our engineers did here is they said, you can actually go look at the call stack where we know the problem exists. You don't have to go find it. We'll find it for you. Yeah. And this goes back to Madhusudhan's question. So I'm going to click the show call stack, and I'm here without PDBs. I'm sitting here to the question that was posed earlier. I don't have PDBs. This is where I potentially, and the PDBs is essentially a reference to allow me to match where my application is running in production to a line of code. It kind of lines me up so that wherever this dump was taken, I can get back to a line of code. Because ultimately, that's what I want to do. I want to figure out what part of my code impacted the situation I'm in right now. And so even though I don't have the PDBs for this, I've got a new option in here that we introduced a few versions back called Decompile source code. I currently have permission to do so. So I'm going to go ahead and click Decompile source code. I'm going to continue on through this very glaring warning. But I promise you, I absolutely have permission to do this. So I'm going to go ahead and hit OK. And what that's going to do is decompile that source code and essentially generate PDBs for me. And what that allows me to do is go back to my call stack and look for my code, and that's right here. And right now I've figured out, again, now I'm looking at decompiled code. This is code that was not on my machine prior to us just sitting here. This is all the information it derived from that dump. It just decompiled it for me, and I'm now able to see where I'm sitting right now. And just by looking at this particular call stack and by traversing the call stack, again, this is something you're used to with your normal debugging. I'm going to go a step down and see I've got a task that is calling do something, and that's where I'm going to go back to that now. And now I'm doing a wait one. So let's go back to my diagnostics analysis and what it was saying. You shouldn't synchronously wait on anything from asynchronous code. Otherwise, you're kind of blocking the thread pool threads, and you block them from essentially being able to service other requests in your pipeline. So this is where we are right now. I've kind of got to the bottom of this one. Low CPU, low memory. Why wasn't it responsive? We ran out of thread pool threads, and this kind of analyzer helped you get there.
This is so great. I especially love having the potential fix there. Like, I think most things will just at best give you the fact that there is an error, but then they don't tell you what the fix is. So then you have to go off on your own and try to figure out how to go about it. So it's like you're learning something in the process. Like, async is not easy to implement successfully and as efficiently as possible. So like, I feel like I learned something new in general from here on out. Just like, don't synchronously wait on monitors, events, and tasks. So there's a great GitHub. If people want to just make sure they know how to do this correctly, let me also drop. Is it David Fowler?
David Fowler's great article on async guidance. Fantastic stuff in here where we see how you can do it badly. He talks about sync over async in here. And GitHub, David Fowler, ASP code, diagnostic scenario. Please check this out if you're doing async code. There's some real great gems in here about how to do it correctly and actually how to do it badly. So avoid those. You'll see them marked with the bad. And here he mentions sync over async, one particular type of sync over async.
So in fact,
go ahead.
Oh no, I was going to say I have this page bookmarked. I love this page.
Yes.
Great job, David.
Definitely. Yes, we need this. We need this. Yeah. So in this example, I had 10 thread pool threads. I used them all because of bad code I had, and this was able to help me.
Yeah, that's so great. And again, that's something that you may not have been able to recognize before it was out in production because all your threads might not have been used up in that context. Also, while we're talking about decompilation and stuff, Madhusudan also asks, thanks for the insights. And will the decompile option work for unmanaged code?
The decompilation option is all about managed scenarios. It is, to be honest. Yeah. So it's about managed in this instance.
Gotcha.
Yeah.
Sweet. And people are asking for the GitHub link, so we'll definitely have to share that in post.
Yes.
Sure. Yeah.
Absolutely.
Great.
All right. I got a couple more scenarios. I don't know how much time we got left, but
we got plenty of time. We've got like a little under half an hour. So
okay. Excellent. Excellent stuff. All right, so let's look at another scenario here. that I think you will enjoy, because I think this kind of ties into some of the work you were doing on parallel stacks. Let's see. So a great friend of mine, Christopher Nassar, has been working, who does a lot of work in the community. He's an MVP, I believe. He does a lot of work in the community and has this great application where he was showing what was essentially a deadlock. Again, I have to give away what the issue is, because ultimately it's in the name of the dump. So I'm not going to give anything away here.
So many spoilers. I'm so disappointed.
Yeah. So in this situation with a deadlock, again, this is a low CPU scenario, right? So your CPU is not going to be spiking, your memory is not going to be spiking, but what you will notice is that your app becomes unresponsive. And so we wanted to kind of, again, look at those kind of scenarios where it's not obvious necessarily what thread is causing the issue just by maybe looking at it. So we wanted to kind of make sure we're showing off how we can get back to using tools that we've improved in Visual Studio to help you diagnose this issue. So again, I'm going to go ahead and start with the run diagnostics analysis with this dump we've collected from an app that had stopped responding to input. Okay, so I'm going to run diagnostics analysis. And it's going to go try load symbols. We'll forego that for now. And wonderful, let's go here. All right, this time it's making these analyzers available to me, and it's going to say, well, it could be a sync over async issue, possibly, right? I've given it away now, but it's obviously, it could also be a deadlock issue. So we're just going to let all the analyzers run.
All right.
And just a few seconds later, it's detected something, and in this instance, it's detected a deadlock.
Everyone's favorite.
Okay. Everyone's favorite. With deadlock scenario, what essentially we're saying with the deadlock scenario is that thread A is waiting on a resource owned by thread B. Simultaneously, thread B is waiting on a resource held by thread A. So they're waiting for each other, and they just can't stop, right? They can't stop waiting. So nothing else can get done, because essentially everybody's going to be waiting for those threads to resolve, and they never will. Right? So this isn't a sync over async issue, but you've done something in your code that allows for this scenario to occur. So anything else that tries to get involved here, it'll be problematic. All right, so let's dig in here. Let's see what this is saying. So we click on this result, and here it's simply noted that the application is deadlocked. Typically, this is where two or more threads are frozen in execution, because they're waiting on each other to finish.
It gave a definition too. I love that. This is so great. Yep.
Yeah, the assumption that I think, what I think of when I'm going through this process of debugging, and I've done, like I said, I spent a few years in the finance sector helping banks debug problems they were having with high scale applications. And what I realized is that folks don't make these mistakes on purpose, meaning they're not in this, when they kind of come up against a new abstraction layer that they don't know about, they don't know about it. You have to provide them some information. Like just telling them it's a deadlock isn't good enough, right? We've got to do a little step further by letting them know these are the things involved in this deadlock, and this is what it means, right? Mm-hmm.
This is great. And it's just, I love how new developer friendly it is. Yeah.
Right. Yeah. That's the hope. So here, in the future, we're obviously working on these analyzers. This is our first kind of round of these. So we're looking to kind of make some better connective tissue between finding the problem and getting you straight to the issue. Right now, it's saying, hey, I want you to go check out your parallel stacks window. We think there's more information that will be helpful to you to solving this problem. So our analyzers right now are in their infant stage, their nascent stages. So we're kind of shepherding you towards the tool that will be best served for solving this problem. So in this regard, I'm going to go to debug, and it says go to the windows and the parallel stacks. I think I actually have it open already. And here's the parallel stacks window. And this is actually my favorite tool in Visual Studio, if I'm honest. I love parallel stacks window because it invites you to take a step back, to zoom out and think about what's happening on the large scale of your application.
Yep. I'm a visual person too, and I love just the visual graphical representation of all of it personally as well.
Exactly. It's like seeing these relationships by seeing a list of threads. I mean, we do have a threads view, but it's not as straightforward. When you certainly have a visual representation, I think it kind of lays out the problem a little bit more. Like right now, I know that there are 90 threads that all have this essentially leading to 1 here and 89 here, right? I know that that's a large portion of my entire application just by quickly looking here. So this is, I actually think when it comes to dump debugging, there's kind of 2 approaches I have. When it's a crash, ultimately I want to get to the line of code as quickly as possible, right? I want to know what line of code crashed. But when it comes to a application that isn't quite responding correctly, I actually want the big picture view. So I want to start at how many threads do I have and what are they doing? And then the second stage I want to get to is, well, what's the call stack of most interest in amongst all those threads, right? And then from there, I want the line of code after that, right? So parallel stacks kind of follows that natural progression of taking you from threads to call stack, and then finally to the line of code that is going to be important.
Yep.
So, so thinking about this then, I have what looks like these deadlock icons. They're kind of stop signs right here, all on these 3. So I'm going to look at that to kind of see where I go next. And the one that sticks out is this one over here. They're all waiting mostly on thread 7048. Thread 7048, thread 7048. Wonderful. I found one that's really interesting. So 7048 is here, but it's waiting on 28964, thread 28964. So let's jump between those 2 threads. In fact, I think I'm not quite in there. So 28964 is right here. So 28964 is waiting on 7048. 7048 is waiting on 28964. That is a classic deadlock scenario right now. So we went quickly from, we don't know why our application isn't doing anything, capture the memory dump, pull it in here, and Visual Studio told us, hey, you've got an issue here, and this is where, in this parallel stacks window, really gives you the information you need to get to the bottom of that.
Awesome.
But we don't stop there.
Still gotta fix the problem.
We've still got to get a bit closer to the problem, right?
Yeah.
And again, this is where if you've got PDBs, you might want to get involved here. So I want to change threads because I'm really interested now in looking at thread 7048. I want to see the condition of that. So I'm going to go to my threads, drop down. In fact, if I hover here, I can just double click on 7048 right here, and that'll switch threads for me. Again, I'm in this no symbols loaded page. And I can go find PDBs if I had them, but I don't. Unfortunately, I'm terrible at my job. That's terrible. That's not true. Wow. I'm decent at my job. And I'm going to decompile the source code here.
Another long contract that you have to sign.
Yes, we have to sign the contract repeatedly. Yeah. This won't be there forever, but it is for now.
While we're waiting for that to decompile, we got somebody, Gertjan, who's asking, where can I find these dump files again in VS? Or I guess how do you open a dump file in VS?
Right, so you would go to File, Open File in Visual Studio, or you can drag and drop them straight into the IDE. So there's File, Open File, and then you can go find your dump, or like I said, or you can drag and drop them. That should work also.
Cool. And then on the topic of just like, how do you even get a dump file? You mentioned a couple, it's like ProcDump and
Create Dump. You can actually use Task Manager. If you right click on Task Manager.
Oh, really?
This is so if you go to Task Manager, this is taking a while for some reason. We may have to restart this one. But if you go to Task Manager, and we go to Edge, right click on here, you can create dump file, right? So you can also do that real simply there as well.
I didn't know that. Yeah. That's pretty sweet.
Yep. This looks like it's not responding very quickly. Let me see if I can cancel that and try it again.
Cool.
Yep. So also, obviously, Task Manager, you can take dumps within Visual Studio as well. So if you go to debug menu as well, you can take a memory dump. So if you're in a tough situation in Visual Studio and you want to share that information with another developer, you can take a memory dump and literally share that dump with them. If you want to show them the parallel stacks window at a particular moment in time, you can take a memory dump. I think this is not necessarily going to come back here.
No, it's demo shy, as I like to call it.
All the time. Demos, gods are not with me today. Let me
I feel that.
Let me deal with this.
Well, we do have some questions in chat while we figure it out.
Please.
So, Grow2 asks, do you have to open the dump file in the correct solution?
No, again, so if you have PDBs, what I like to do with PDBs, just like I'm getting ready for like a new build in production, what I tend to do is make sure I know which PDBs are associated with which application I've just deployed to production. And so if I've done that correctly, what that means is that whenever I open a dump, I've got the right PDBs in place. But if I don't have the PDB set up, maybe that's not a part of my process. Like I said, you can use decompilation to kind of get to the line of code if you need to.
Okay, cool. And also just as a brief, how do you open the parallel stacks window, as Morish asks?
Sure. Parallel stacks window is also under the debug window. So if you go under debug and in fact, let me see if I can bring this back up. I'm almost there.
No worries. Also, just global search. That's how I locate parallel stacks.
Yes, global search is our friend.
Yep.
Because there's so many shortcut keys. There's so many features you've got to choose from.
We both work on Visual Studio, and I couldn't tell you where half of the stuff is in their respective toolbox. Just use search. Yeah. Also, we've got a question from Mr. Sossenbinder. Are there any plans to make it more intuitive to also peek into external code when analyzing dumps? I always felt like the just my code options are a bit hard to access. Is that on purpose?
So I don't have a direct announcement for you yet, but keep an eye out on Dev 17, the stuff we've got coming for Dev 17. We have been really thinking about the space of when and where things like tools like SourceLink might come into it, things like when decompilation might be. And SourceLink, by the way, is the ability to embed in your PDBs and your assemblies information about the source location for that particular artifact. So if we can point, for example, if we know that you have information over at GitHub, we can potentially point you to lines of source that existed in GitHub. So yes, we really are thinking about how to make that whole process a little bit more intuitive, a bit more direct for folks who kind of want to look at, if an exception occurs and it's in a third-party library and that third-party library is happy with you kind of looking at their code, it's maybe on GitHub already, something like, the JSON converter or what have you. In those scenarios, we want to make sure we really have a first-class set of workflows for you, so that you can see exactly why that third-party application is responding the way it is. So we are really thinking about the space. And if you have ideas here, I would love to talk to you, Mr. Sossenbinder.
Yep, do share. And Mark's Twitter handle is below, so feel free to ping him. We do listen to what y'all have to say.
Yeah, totally.
Yep. Siva asks, can the VS tool be leveraged to ARM GDB as well? I'm not sure what that is, but
VS tool be leveraged. So I'm assuming that means that we can we dump debug a managed application running on ARM. We've done testing against about 5 different Linux distros, and I'm not sure that included the one you just mentioned, to be honest. So if that's indeed your question, it would be it would be great if you this is something that you've tried. Please let me know if it fails. I'd be happy to kind of follow up with our developers here and engineers here just to check and make sure that's something that we're going to support or supposed to support. But to be honest, I'm really not sure.
Cool. No worries. And the most important comment of the day today. No Mercy loves your shirt.
Thank you.
I love your shirt. Your shirt's pretty awesome.
Yeah, cheers.
Sweet. I do want to note, this is also a bit of a plug on the top, since we've been talking about async and parallel stacks window a lot. I recently recorded with Isidore Verdopoulos he's also on the debugging team, and we're going to do a 3-parter that's going to be pre-recorded on async debugging specifically. So be on the lookout for those episodes in the next couple of weeks if you're interested in more async stuff. But yeah,
that's really cool.
Yeah, because async debugging is really cool. It's also really hard. So
yeah, it certainly has its quirks, and it's something that I'm always kind of trying to think of ways we can talk about it so it's easier for everybody to do. So I completely agree with you.
Yeah. I'm loving the pun game. Terrence, I guess we'll have to await the episode.
Yes.
Good job. Good job. All right, so hopefully it loads up again. Second time's the charm.
I literally ran through every single demo and it all went flawlessly.
Right? It's always
the Schrodinger cat. I think it's the Schrodinger cat kind of experiment. Like it's you don't know whether it's dead or alive until you actually start recording.
Right, yeah.
It's
when you open the box. It's like, oh man, I was wrong. It was dead.
Yeah, it was actually the whole time.
I had that problem. I was demoing some debugging stuff like a couple weeks ago on a different show, and it was serious. Yeah, I was working like 5 minutes before, and then Visual Studio just did not want to work. It was just like, all right, nope, you're just not even going to open today. That's cool.
Yeah.
Thanks for working 10 minutes ago when that wasn't important.
Yeah. So where this would have ended, I mean, just as an FYI, this would have ended with essentially me being able to show you exactly where we go into the system threading monitoring enter lock right here. As you can see, I kind of in this buy kind of option, what actually happens is literally as you'd expect. What we've done, the error that was made in this code quite deliberately kind of for the demo purpose was a lock on an order and a lock on a seller. So you have two functions, one that locks on an object, which is basically saying, I own this, and until I release this lock, you can't do any processing. And another thread's doing the same thing. But whereas the first thread starts with lock 1 to 2, the second one starts lock 2 to 1. And so in order to fix this, basically with deadlocks, you are in a situation where you've locked resources in the opposite order. And so really what you need to really do is lock them in the same order. So if I have a lock, I'm entering the lock and I'm trying to make sure my code is safe, you want to just basically make sure they lock in the correct order, both threads. So I'm going to switch to I'm going to attempt to switch to another of my debugging sessions for the finalizer queue analyzer, and I'll call this one "I am defeated." Oh. I was so looking forward to nailing that one.
I know. It's always like the most anticipated one where it's just like, nope, I'm not going to work today.
Not doing it today. That's so funny. Right. I see Escobar suggested we need a dump file from VS Studio. Yes.
I support that.
Yep.
Oh, it's so great.
Yep. Hilarious. Okay. Yeah. Let me get that going. Any other questions? Let me know from the
cool.
See if I can.
No questions from the here we go. Yeah, Warren asks, what advice would y'all give to a person looking to get into coding? And what's your thoughts on boot camps and 14-week programs? It's a good question. My personal advice, I don't really have experience on the boot camp side of things, but as far as getting into coding goes, just give it a try, honestly. Just I personally watched like a lot of YouTube videos and like this one or other things, and I just thought, like, think about an idea that you're passionate about, or like an idea for an app, and just go for it. I think the beauty about computer engineering programming is that you can kind of just, as long as you have a laptop, you can really just get started anywhere. And yeah, you'll have to go through some trial and error. You'll definitely be frustrated at times, but I think the more you do it, the more you'll improve and the more you'll learn, honestly. And there's just a lot of great resources and stuff out there where you can get started on whatever kind of project that interests you. And I think you'll get there.
Yeah, I got to agree with you there, Leslie. I think it's really about exposing yourself to coding as much as possible. And boot camps are one way to do that. Obviously I've got no particular endorsements. I certainly haven't done a boot camp myself. I had to be exposed to coding through either school or I did take a few courses outside of my actual schooling. For me, it was really about repetition. And so I think what boot camps kind of let you do that kind of repetition, getting used to a particular area and space. I'd also suggest looking for somebody for a mentor in the space as well, somebody who can help you. If you have time, the luxury of time, and I know not everybody does, but if you have the luxury of time and you can kind of get involved in an open source project, that's another way to just kind of expose you to a set of, features that are being developed or problems that are trying to be solved. Look for a good community to kind of connect with. There are coding communities out there that kind of look for folks who are relatively new and kind of look to offer mentorship. So I'd look for any scenario where you can kind of rub shoulders with folks who are kind of happy to kind of provide you with kind of next steps. I think that certainly helped me a lot. I needed somebody to kind of give me the prompts and the help to kind of get set up. So
sweet. All right. So Mark, do you have like one last demo to close us out?
Yes. So the last one I really wanted to talk about was a finalizer scenario. So finalizer is not something we necessarily talk a ton about in managed spaces, but as folks, certainly when I was coming up, C++ was much more of a big deal. And so you may have kind of thought about it in terms of a destructor, but either way, it's this kind of like we kind of usually assume that the GC is going to clean up artifacts for us. So we don't think about closing things out or destroying them ourselves or destroying them manually. And what the finalizer does is allows you to maybe clean up artifacts that the managed side of the world doesn't necessarily know about. But when you do that, you have to make sure that you clean it up correctly. And the reason why you need to make sure you're going to clean it up correctly is because it's going to make your objects hang around for much longer. And because they hang around for much longer, and if you do it incorrectly, you might actually end up having them hang around for much longer than you expected, which leads to bloat, which leads to memory size being unnecessarily large. So ultimately, if you are going to use something like a finalizer to clean up resources in a class or an object, you have to make sure you do it correctly. And we found some very narrow use cases around the idea that the finalizers were not correctly cleaning up resources. And so we created this really obvious way for detecting that you have a problem with your finalizer queue. So like I said, rather than when your object goes out of scope, the GC will take care of it. The finalizer queue is basically another queue that says, if you have a finalizer, I'm going to clean you up at a later time, right? And so we have a warning right here. Again, this isn't necessarily an error. The reason why it's a warning is because ultimately, in some cases, this may be just the way things are for you. You may have to have finalizers, and having a lot of things in your finalizers is fairly normal. But ultimately, we wanted to kind of call it out as something to be aware of. So if I click on that finalizer, it's basically telling me I have almost 100,000 instances of this object in my finalizer queue. It's essentially telling me you probably want to take care of that.
Maybe,
and that's actually, I think should be pretty obvious to us here. And in fact, it suggests, in addition to that, it also suggests you may want to use the much more contemporaneous implementation of cleaning up objects using the system I disposable. That's a kind of a much more .NET based, much more it's the suggestion that I think most developers would use these days for cleaning up native constructs. So anyway, one thing I want to do is switch again. This is a kind of a newer analyzer. We don't have a direct link to the thread here, but I'm going to suggest that we actually go to the finalizer thread. So if you look at your list of threads, you have the main thread where we started. We have all these threads here that are doing various work, but then we also have this GC finalizer thread here. And I'm going to switch to that. I already did the decompilation because I was scared it wasn't going to work for the third time. But this would have required decompilation because this particular piece of code is actually part of my custom code. So I've decompiled this code. And this is my finalizer right here. And that tilde indicates that this is the finalizer for this class. And as you can see, I've done something rather silly. I've done a while true and have nothing. So you can imagine here, if I was cleaning up resources, maybe it was cleaning up a file location and this was taking too long, or maybe database records needed to be cleaned up, but the database call was really, really long. What that would mean is I would get this list of finalizer objects, each one of them taking multiple seconds to clean up. And inevitably, I would build up, my application would start growing and growing because this particular class wouldn't be able to clean itself up. And the GC is saying, this is the job of the finalizer queue to clean up. So obviously, whatever we have inside here needs to be quick and efficient and not fail because we want to make sure that our app gets cleaned up appropriately.
Cool. Yeah, this is all great stuff. And yeah, I hope more and more people take advantage of these tools because it's really great from a production standpoint, I'm sure.
Yeah. I think people probably don't realize that you can use the same tools that you've been developing with to kind of help you in a kind of post-production kind of scenarios.
Yeah.
As you kind of find problems and you say, okay, it would be great if I knew what was going on at this moment in time, then memory dumps are a great way to start thinking about analyzing things in retrospect.
Mm-hmm. And as you mentioned, yeah, a lot of those tools that you're using to debug these dump files are the same tools that you use normally when debugging.
Yeah.
So yeah, that's great. You don't have to like learn a whole set of new things in order to
absolutely. So to be clear, so I can go into my locals, I can go into and use my depth searches, the stuff that I know that you worked on. I can search for values, I can use autos, all these kind of the immediate window, all these things that I kind of used to using as part of my normal debugging are all still available for you, even if it's a memory dump.
Absolutely. So, Mark, where should people go in order to learn more about this stuff?
There is we have new docs on dump debugging, specifically around the analyzer. I'll make sure I drop the link. Also, we have new, if you go to our Visual Studio blog, I do a lot of blogging about production diagnostics, dumps, and looking at memory dumps. So there's going to be a ton of resources there for you to check out.
Awesome. Well, Mark, thank you so much for coming on the show today. This was really great. I hope everyone learned something new about dump debugging and memory dump debugging and why you should be using it. Right. And yeah, love to have you back because debugging is always a hot topic for a lot of people.
I'd love to be back. Thank you.
Yep. And also to give in another plug, tune in tomorrow at noon, I believe, where we'll have a special episode all about what's new in Visual Studio 16.10. So if you haven't hit update on your version of Visual Studio yet and want to know what 16.10 is all about, be sure to tune into that to learn more. So until next time, happy coding. All right.